Let's see more things which are important in Python. These are not structured as some kind of things, but they are. This will help you to write your code and will help you to understand the Python code easily. Let's see one of them. Scopes in Python. What is a scope? Scope is an area or the positions where a variable can be seen. So when we define a variable inside a function, what are the places where we can actually see this function? Sorry, the variable. So what are the places where the variable will still be defined? Obviously, if we define this variable inside a function, we can have this function anywhere inside the function. But even after calling the function, the variables, all the variables which are defined inside the function uh, are erased and we cannot access them outside from a function. And the other scope is a global scope where the function is defined at the same place where the variable was defined. Now that variable can be seen from inside the function, but the variable value cannot be changed from inside the function. The value will retain its status in the global scope and it will replace and it will change its value in a local space or a local scope. Let's see this in code to get a better understanding of what is a scopes. So let's see, we define a function called fun and we don't have any parameter for it. We have a name variable whose name is local. And now we print this name. Now we call this function and here we try to print this name variable. Let's print, let's call our file and here we got name error. The name and quoted name is not defined because the name is not defined in this space or in this scope where the function is made and where we are printing the name. The name was defined inside the function scope. Now let's give this variable name equals to, let's remove this. Now let's give this name as a local value and then include this name in parameter and then see what it does. Can we access this name from outside a function or not? Again, we first see the local printed because this function was running. Then we tried to get the value of the name, but the name was not defined in the scope. Name was only defined inside the function scope. Let's try to change this way by defining the name in a global space or the global scope. And then we don't take this parameter as an input. We first print the name, then we change this name to local, then we print this name again. And we don't have to give any parameters to the function now. And at the end, let's try to run our code. We got a local variable name undefined because this name was not defined inside a function. That's why this global scope was different from the scope inside this function. Let's remove this. And now we have a name variable inside the function and one name variable outside the function. Let's try to run our code, and we first see the local get printed, and then the next line the global is printed. This is because here the name, uh, which is a variable name, is actually having a value of local and whose scope is only just within this function. While here printing the name, we don't have this parameter available now. We are in the global scope, so this name parameter value will get printed, and that's why we got global at the end. Now let's see if we want to use the variables defined inside the global space, what can we do? So there's a keyword in Python named global. We can use that as we have this keyword global, then we can add the names of the variables which we want to use inside the function and don't have to import it or don't have to give it in the parameters while defining the function. So the name, we say the global, then the name. So this name variable now changes its scope from global to the local. Now let's print the name and again change the value inside this variable to local. Let's run our code. We see first our value was global, then the value got converted into local while final printing. This is because this is the same variable whose scope we changed from global to local here, and while going back to global, it retained its value as it was defined in a global space or a global scope, and that's why at the final, if we print the name, the value which we got was local. This is the use case of global keyword in Python. Using that, we can change the scope of variables and actually change the variable inside the code. Python modules. If you have a function defined in one file, and that is quite a big file, and you have another file where you want to use that function, but you don't want to rewrite the whole function as it's already being written in that file. This is where the modules comes. A module is nothing but a way to import something or some function or some value from another Python file. So let's see this with an example. Let's close this, and here let's create another file, and let's save this file as app.py file. And within this app file, let's write a simple function. Let's say define, and within this function, we can say print this is an app file. Now this function is in the same place where our hello.py file is. And there's a function written inside this app file. We want to use that function in our hello.py file. So what we do is we import that function from app file, and to import it, we say from app. Remember, we don't give the full name of that file. The .py extension, we don't need to add it here. From app, which is the file app.py file, we say import then the name of that function, which is fun. Again, we don't give the parentheses, we just need to give the name of that function. Now let's call this function. As you can see, we have not defined this function here. We are importing this function from the app file. Let's run our code and we can see it prints this is an app file. So we are importing the function written in one file and executing and calling them in another file. This is how you can do that. Let's get back to slides. So this function was in file 1 while the application or while the function was being called in a file 2. Similarly, right now what we did was we had the files in the same folder. What if we have these files in different folder structures? Imagine there's a project folder and inside it there's a main.py file and your app.py file is inside the folder 1. Then inside that folder 1 there's a folder 2 and inside that folder 2 there's an app.py file. Now you cannot directly say from app import function. This is where we need a relative import. So to include such files, we first thing we need to do is we need to have our dunder init.py file to be located in the project folder and in all the folders where we want to access the files. What it does, it makes the whole folder as a package. So Python can access each of the folder and can uh, access all the files, Python files within the folder structure. Let's see with an example here. In our code editor, let's close this file. So let's delete this app.py file we just made. So we are in our project folder. Inside this project folder, we have a folder 1. And inside this folder 1, we have init.py file and a folder 2. Inside this folder 2, again, we have init.py file and app.py file. Let's open the app.py file. As you can see, this app.py file has this function is from app.py file. And we can say one more thing. This file is inside folder 1 and folder 2. Let's save this. While here, this is the hello.py file, which is in directly the project folder. Now we need to relative import this app.py file and then import the function. Let's delete this. So here we can say from, for relative importing, we use a dot, then we say folder as it is first inside the folder 1, then again dot, then we say folder 2 as it's inside the folder 2, then we say the name of that file, which is app, not we don't include the last .py, remember that. Then from this relative location, import fun, which is the name of that function. Let's save this and run our code. This dot must not be here. Sorry for that. So let's save our file and run it again. You can see this function is from app file, and in the next line we got this file is inside folder 1 and folder 2. So this is how you do the relative importing in Python. Let's get back to our slides and know more of these features. Next, we have the built-in math library of Python. You can use this library to do a lot of commonly used math functions like minimum of the numbers, maximum of the numbers, or the absolute value for any number, or you can use a power function which gives you the power of any number with any other number. To use this library, you must import math at the starting of this uh, code, and to use the uh, functions inside this math library, you can use dot like we use uh, to get the method from an object, treat this math as an object, then use the dot and then the name of the methods we want to call, like the square root. We can do that using math.sqrt. This will give us the square root of the number which we give inside this function. Similarly, there's a ceil and there's a floor functions inside this math library. You can try them out and look for different functions and methods inside this math library, and this might come helpful in further math projects. So this is how you import the math library. Finally, what is a package and what is pip in Python? Pip is nothing but a Python installation package manager. So there are a lot of libraries available in Python. We know that that's why we are learning about Python, because it's wide availability of the libraries written by the Python community. So to use those already written codes or the libraries, we use pip to install those libraries. You can use pip install, then the name of the library which you want to install. You can run this in the terminal. Let me show you how you can do that. This is our terminal. Here, if you write pip install, then the name of the library like numpy, then hit enter, it will start installing. In just one line, you can install the widely available libraries or the internet of the Python and use them in your project instantaneously.